to start with a bit of a story. Hopefully you can relate to it. You're a developer, you get a call on the weekend. Your change that you pushed through on Friday night has unfortunately meant that a couple of clients can't close out their payments on your app, so you now need to go ahead and fix it. It was quite a big change that you put in, so you and your team now spend the next few hours trying to figure out what went wrong, how do we get this wrong, and then what can we quickly do to fix it. Within a couple of hours, you have solved the problem. You've realized we have found what caused the issue. Let's quickly put the code together. You try and do some quick testing, but obviously this is quite a critical issue, so you don't want to spend too much time doing that. So you're like, well, let's just run some unit tests, push it through our CI/CD pipeline, and let's go to prod, and we're good to go. Everything looks good. You go through, your CI/CD pipeline runs, passes. You have pushed into production. You have solved the issue. However, your code was not really optimized, and within about the next day or two, it's starting to cause some performance constraints on your system. And the way you've configured your cloud and everything is not quite load balancing correctly, and everything goes down. Your fix that was there to try and solve a couple of customers who couldn't close out a payment has brought the entire organization down. Hopefully this is a bit of an extreme example and this hasn't happened to you, but the reality is this is something that we're often faced with. And the challenge it brings us as software engineers and software developers is we're now trying to push code. We need to get things out quickly, whether we're trying to push small, immediate fixes, we're trying to push new changes, or we're just trying to even get a bug into production. We need results quickly. We can't sit and wait all day to try and push something into production. And that's what CI/CD pipelines are supposed to solve for us. How do we get this into production as fast as possible? Our CI/CD pipelines ran. Why did it fail? What went wrong? And because of that, you lose trust. Because you start to doubt your skills, you start to doubt your trust in your entire ecosystem. You no longer want to make changes, you no longer want to push through things. It slows you down because now you want to be extra cautious. And perhaps more severely, the business doesn't trust you either. So how do we solve this problem? How do we restore that trust in your code and your code confidence? It's about building automated quality gates into your CI pipelines, which we'll talk about now, and which hopefully gives that confidence back to you. A little bit about me, for those who don't know, my name is Craig Risi. I am the head of engineering at Old Mutual, looking across how we do software engineering across the organization. I do blog a lot, so I've put my website down there, and I also have a GitHub repo, which some of the code I'm going to go through today will be on. So if you ever want to go in and have a look at some examples of CI/CD pipelines, there are a few there that you'll be able to find. I also do board games, so riskygames.com, where you can find my board games. I've published 12 board games, and they're available for free if you're willing to print them. So you're welcome to play there. I also have a book out called Quality by Design. Some of the stuff I talk about today is in there, but it's really just about looking at software differently, and we're sort of focusing on software testing and automation, how you focus on quality. And I have got a new book coming out next month on software architecture, on the fundamentals of software architecture. So be a lookout for that one as well. I think it'll be an exciting book for people that believe in software architecture being a vital role in the software delivery process. But let's get back to CI/CD pipelines. Again, CI/CD pipelines were really been touted as this is going to be the future of software engineering. This is going, it's how we're going to be able to develop software quicker, more stable. It's supposed to improve quality, but the reality is they can be quite tricky to manage. DevOps, DevSecOps skills. I think we're still finding our feet there. We're struggling with a lot of the skill sets. We're not so sure how to do it. I think we often all end up doing our own thing, and we're all just trying to be cowboy and trying to put this thing together. And the reality is the quality of what's coming through our CI/CD pipelines, particularly in large organizations, tends to be all over the place. You think you can trust it, but the reality is there's constantly things going wrong. There's constantly mistakes that are going into production. And like I said at the start, it affects the confidence that you and your organization has in what you're able to deliver. And that's why so many companies tend to spend so much time on wanting to do manual testing, on wanting to do all these checks. And again, I'm not saying manual testing is bad. I'm not saying these checks aren't good, but it defeats the purpose of CI/CD pipelines. The whole idea of continuous integration, continuous deployment is we can do this quickly. We can do this reliably. We need to build that trust in it, and we need to solve these problems. CI/CD shouldn't be a problem for us. It shouldn't be a curse word. And hopefully, if you were at the last talk that Donald did, he was able to convince you of some of the things you need to do. But quality gates, I believe, are the key thing that really start to build that trust within a CI/CD pipeline, and the thing that we need to do to be able to do it properly. What is a quality gate? For those of you that might not be familiar, essentially, it's just a change control. It's really just a check to be able to see, does this point in my life cycle match what's expected of me? You would think about it more of like your entry and exit criteria. When I started out in software development, we often used to have these entry and exit criteria. This is ready for development, this is ready for test. It sounds very waterfally, but the reality is if we don't have some sort of measurement of criteria knowing I am ready to code this, or I am now ready to move this on to the next environment or my next phase of my CI/CD pipeline, again, we're just introducing problems into the system. We're losing trust in what it is we're building. It's there to prevent development from moving to the next stage, until there's certain measures met. But importantly, it needs to be automated. Again, if we're doing CI/CD pipelining, but now we're still keeping with a lot of manual checks in the process before we go to deployment, you're not doing CI/CD, I'm sorry to tell you. You cannot have a CI/CD pipeline if you're still relying on manual checks and balances. This works when you design it and when you think about how do you automate every step in the process. And a quality gate needs to be something that is automatable and that you can automate. And that's an important thing to get there. Why do we want them? You need to drive consistent quality at scale. Again, if you're in a small team and maybe you only have one pipeline, you think, why is this an issue? Maybe you don't see it. But if you're a large organization where there's 100-odd teams working together, you've got 400 different pipelines running across the organization, just a couple of teams constantly delivering bad code into bigger environments can cause a problem. And I don't know if there's any testers in the room, but some of the biggest frustrations that testers face is when the developer says code's deployed into the test environment, and then they start to run their automated tests and everything, and things are just falling over. Because your code did not deliver what was expected. If you, as an organization, want to be able to move quickly and want to be able to deliver fast, you need to be able to do that at scale. Quality gates ensure that every single team's version and definition of quality is the same. We shouldn't have some teams doing it great, some teams doing it poorly. Every team should be trusted and have the same standards. It drives a shift-left mindset. When you start to think about how do we introduce a quality gate into our CI/CD pipeline, it changes the conversation to how do I test this quicker? How do I design this in a way that I can test it quicker? How do I design it in a way that I can automate this earlier? It changes the way you think about your software design because you're thinking about the testability and the automatability from the very beginning. It obviously can safeguard you against poor code introducing later testing cycles, which I spoke about, but it also prevents that testing thing being impacted. I think we often feel we want to deploy, we want to deliver, but there's all this testing that needs to get done. And obviously, if it's automated, that solves the problem. But even if there's elements of manual testing, or we still want to get through the process, we shouldn't feel like it's taken us 2 weeks to deploy, but into a test environment. Now we've got to wait another 2 weeks to get the testing done, or we've got to try to squeeze that testing in. It allows the whole thing to happen a little bit more seamlessly. But most importantly, it ensures proactive quality. Your team is no longer now reacting to problems and constantly only addressing the pipeline every time there's a failure. Oh, something failed, let's check the build, something failed. Because you've got really strong quality gates in process, you're catching stuff. You're catching stuff early. You're going to get to the point where if something does go wrong in production, it's probably pretty severe. And you probably would have never been able to think about it anyway. It's no simple mistakes that are going in and causing problems. It really allows you to drive quality from the get-go, which I think is important across any organization. Now, some of what I'm speaking about now might sound incredibly difficult for you to do, but it's important that if you're going to make quality gates work, and particularly CI/CD pipelines work in general, that you have building blocks within your organization or within your team. First is it does require well-defined and clear completion criteria. You need to measure your quality gates against something. What is that? What does good look like to you as an organization? What does good look like to you as a user story? What does good look like to you in your code? What does good look like to you in testing? What is good enough to go into production and deployment? If that's not well defined, what are you building a quality gate against? Because this is automated. This is not a look and feel, yeah, I feel like this 95% confidence that this is going to work. It needs to be definitive. What is good enough? If you don't have that, it's very difficult to get this right. Testable architecture. I really believe that architecture is one of the key foundations of making software work. And if it's not testable, you're going to run into a lot of problems with getting something into a CI/CD pipeline. What does that mean? Well, just think about unit tests. As a developer, if I'm struggling to write unit tests for my code, maybe I need to rethink about how I'm writing my code. Because code that's difficult to unit test is probably very difficult to maintain, and it's going to cause a lot of long-term pain. And then you want to talk about automating all the integration and end-to-end stuff, you can forget about it, because if you can't unit test it very easily, you probably can't do the other stuff very easily either. So again, it's that whole shift-left mindset. It's very important that you have testable architecture and that you drive that in mind. Obviously, it requires us to have a strong focus on unit, component, and contract testing. I believe those are key building blocks that you need to put in place. And I know Donald mentioned it in the previous talk, where he said you don't need to do end-to-end testing necessarily. And I believe that. I believe if you do a good job at these layers, the amount of end-to-end testing that you need to do is greatly reduced. Sometimes almost not needed at all, because you've got to have these foundation blocks in place. And as an organization, as a team, you need to be striving towards how do you put this in place. Yes, it does require integration testing. Yes, it does require automation in that integration testing, because you've built your component tests, you've got your contract tests, some things are going to need to be mocked, you're going to unmock them in some environment, in some way that you need to automate. It does require you to have that. But again, that's just then how do you build that into your system and your process to ensure that as an organization, you're not now needing to spin up and do lots of long manual test cycles to try and make sure something works. How do you automate that and automate the right thing so that you're not focusing too much on your long end-to-end cycles, but you're focusing on the lower level of your testing. So if you're doing a lot of contract testing, you're doing a lot of component testing, you need to do very little of the other testing, and then your integration tests become a lot more easier to automate because you've taken care of everything. And then lastly, it works best with small, frequent releases. As an organization, if you're still trying to push through monthly or quarterly release cycles, you probably shouldn't be doing CI/CD anyway. What's the point? Like, the whole point of CI/CD is regular deployment. How do you deploy on a daily basis? Yes, we sometimes think of it's just the CI part where I'm just going into a test environment on a daily basis. That's useful, but the CD part is the deployment into production. Just as important. If you're just focusing on how you're deploying into your test environment on a daily basis, again, you're missing out on what this is actually about. That CD portion is equally important. I'm not just trying to get something into my test environment, I'm trying to get it into production. And that's an important measure. It's important to do that. And the best way to do that is focusing on small releases. Those are the building blocks. If you as a team or organization don't have all of them, that's okay, you can start to work with it. But it is important that you have these building blocks in mind. It is important that you understand that there are some things that you want to have in place in order to get the most out of your CI/CD. But now, what does a quality gate check? So we're still talking about quality gates. So what do they check? What are some of the things that you can check in a quality gate? And this is not an exhaustive list. There's a lot more that you can check. But just some examples of things like build health. Did your code even build healthy? Like, yeah, there were no errors in your code, but you've got 516 warnings. Isn't that a problem? Like, aren't you worried about that? Again, what's the definition of good for you? Are you okay to just live with all these warnings that pop up all the time? Maybe these are some things you need to consider when you're building your code. How do you reduce the technical debt and manage it at the start? Your build health. Your infrastructure health. What's the point of deploying into an environment that you know is currently unstable? And then when the test fails, was it your test or the environment? do an infrastructure check. Make sure that everything is healthy, that everything is passing before you deploy your code. That's a quality gate that you should be able to check. Test results speak for itself. Code coverage, an important measure, and I'll go into a little bit more detail later, but code coverage is something that you need to be able to put in there. Is code coverage a perfect metric? By no means. Does 100% code coverage mean everything is working? Absolutely not. But again, it's something that is an important measure that can help at least ensure that you've got the right testing mindset in process. And it's a good thing to be able to put into a CI/CD pipeline quality check, because it's very quick and easy to be able to measure that and be able to have a definition of some level of good, of how good the code is at a level. Your security scans. And you can adjust this to how you want, but why wait to fix security later in the cycle when you can catch it before deployment? Or you can even catch it at the first PR and say, hang on, there's something wrong with the scan. We ran a scan on your code, we're not comfortable, PR not approved automatically. There's things that we can do to prevent bad code affecting us later in the cycle. And the whole point of CI/CD is to reduce technical debt. Build it into the process. Service performance. You can actually performance test in a CI/CD pipeline. That example I gave at the start, when I told my story about the performance thing, there are checks and balances that you can do to ensure that code is performant before it goes into into production, and you can use your CI/CD pipelines to do some of that. Now for some different stuff that maybe you haven't thought about. What about incident and issue management? We're all about our pipeline passed, everything's okay. Maybe you think everything's okay, but there's still some issues on the Jira ticket that haven't quite been resolved. Maybe it's a question, maybe it's a bug that someone's raised, but your unit tests don't catch, so your pipeline will still go through. You shouldn't deploy that, particularly if that's quite important. You can actually go and send, through an API call, send a message to your API, to your ticketing system, whether it be Jira, Azure DevOps, GitLab, and it can come back and say there is still something outstanding on this particular code or user story that this code is linked to. Don't deploy. Make sure you iron out what that issue is before you deploy. Again, you're safeguarding yourself. And then deployment and rollback. This, again, might sound obvious, but how does your CI/CD pipeline process deal with deploying and rolling back? No process is foolproof. And even though this is proactive quality, there's a chance something goes wrong. How can your pipeline pick that up and roll back? And how have you tested that within your pipeline process? These are all quality gates that we can build into the process that give us that quality, give the company confidence, give you confidence that your code is not going to fall over in production. Types of quality gates. I'm not going to go through these in detail, but set up and checkouts. Just, again, setting up your code, checking out your code, setting up an environment, setting up your VMs, whatever it might be. These are things that we can check. Your build, we can check. When you're executing, before you do a deployment, after you do a deployment, what are you checking? Your environments, are they ready? Static analysis, do you have them in place? Integration test execution. Dynamic code analysis. Maybe you're running mutation testing. You've run a whole bunch of unit tests. Your code coverage is 100%. Your mutation test fails. There's something wrong with your unit test. If your mutation, if your mutation test failing, it means that there's a clear disconnect between what your unit test is doing and what your code is able to do. Maybe something you should consider, but there's something we also got to factor in is, again, these are all checks that we can put in place. Non-functional test execution. Again, this is something that we don't always consider within a CI/CD pipeline, but it's a quality gate that we can put in. We don't have to leave that for a later cycle. Some examples, and these are basic ones that we've probably already touched, but linting standards. Your linting standards need to be met before the code build can be successful. I think this is probably the easiest thing to do within a code repo, is just scan it, check it, say, does it match certain linting standards? If not, this person's PR request automatically is declined. And again, you might think, but it's just linting. But again, think about it at scale. If you're in a large organization, if just a few developers are submitting code that doesn't match certain standards and patterns, that becomes a future maintenance problem. And you might not realize that it's slowing you down, and you might think, yeah, but this is just slowing me down, trying to change my code to always match this linting standard all the time. It's a big long-term problem. You've got to think proactively around that. You can use your quality gates to prevent bad code, or even if it's good code, but code that doesn't match your standards, push it back. You obviously want to make sure that your tests pass. You want to have a high enough code coverage as an organization that you're willing to trust your code. 90% code coverage, I think, is actually a pretty good metric to hit. And I'll say this because I know it was asked in Joburg, why 90%? There is no mathematical or scientific method to tell you that 90% is the right number. My personal opinion would be 100%, but it's unrealistic. So you've got to find something that works for your organization. If you currently have 20% code coverage in your space, and you set a target of 90%, and it's quite a big code platform, you're never going to deploy because the team is going to take so long to be able to get there. So you've got to maybe find ways of iterating and working. But as an organization, what standards are you putting in place and how are you finding that? You obviously want your scans and your security scans to come back with as good results as possible. You want to have all your automated checks run. And then, like I said earlier, you can even go and then check something around your defects, your user stories, your features, what's going on there, what can you pick up from your other systems that live outside of your code repos. These are examples of quality gates, taking all the previous definitions and description I've given to be something that's a little bit more defined and specific. And all of these are measurable and can be put into a CI/CD pipeline. This is an example of how a quality gate essentially looks. Basically, code comes in, whether you're committing or you're deploying or you're doing something, it would check to see if within your CI/CD pipeline, you're doing some form of comparison or check, and then from there, then determining what needs to do it. And if there's a failure, it needs to identify and tell you if there's a failure, this is what the quality gate failed, and if it is successful, that you're great, and then from there you can move on to the next phase of your pipeline. Here's another way of looking at it, and this is perhaps maybe a little bit more of an advanced one where you're now trying to work with multiple different systems and how do you get them to work together. You'll obviously have your local code where your developers are pushing, and you will basically have this kind of being a branch for every single thing that you're doing, and then your verticals are the different types of tests that you want to do, and you can put a quality gate at every little thing to make sure that everything's been done. So when I trigger my build on every commit, what am I doing? Then I'm now pushing it into a certain type of branch. What checks are going on in that branch? I put it into some test environment which is now unmarked, and I can now run bigger tests. I'm going to run another pipeline to be able to then check that against there. And your pipelines get quite extensive, but at every single stage, it's iterating on itself and getting better up to a point in time where you do this right, you can even drop that end-to-end part. It becomes less and less critical because you have built so much trust through the process. And again, you want to get there to a point where you're deploying to production safely and securely. That was an example, largely looking at quality gates within just the CI/CD pipeline process. And although some of this stuff doesn't sit within the CI/CD pipeline process, I do want to talk just briefly about quality gates across your entire software development lifecycle, particularly focusing on your analysis. And these are things, by the way, you can put in a CI/CD pipeline process. You might think you can't, but like validate the architectural schemas. Has the architect signed off on this? If you configure Jira a certain way and you create a field, you can ping Jira and say, has the architect ticked the box? No, sorry, can't submit your code. Architect hasn't signed off on something. These are things that you can start to think about. Testing, is the right documentation in place? Maybe you've got documentation standards. You're deploying releases that need documentation. Is there an actual file that contains the documentation? Now, you're not going to go scan the entire documentation, but maybe just checking that that file exists is good enough. Again, what's the definition of good enough? But these are things that can even go outside of the code cycle that we can put into our pipelines, and we should even build pipelines that monitor your operations. We always talk about observability and stuff, but again, what actually happens once we get into production, we can actually start building additional quality gates to see how things run. So don't just think about just your code portion. A quality gate is something that covers the entire software development lifecycle, and you can introduce those measures into your CI/CD pipelines and still use it to control things. We're going to get into a little bit more of the how to do quality gates. I've been speaking very theoretical, trying to explain everything, why they're useful, the building blocks, you need to put them in, some examples of them. But let's look at some of the technical stuff that we can do to implement quality gates better. Here's just a brief example of an Azure quality gate and how that looks. just basically showing how you would want it to work. You'd have an Azure board. As a developer, you go through, you push code in whichever IDE you're using Git, pushes it through Git. That Git would then trigger something, and then your pipeline would run a job. So again, let's go back, other direction. That pipeline would run a build job here that runs a whole bunch of things. Where you want to get a source installed, whatever you need to, you can build this all within a container that can run and do all of that. So you would build one job, package everything, run your test, do your quality gate, package your artifacts, publish it, and then push it on to the next phase. So effective quality gates will generally build on multiple pipelines. You won't have one long, massive 300 coded line pipeline. Well, you shouldn't really. You'd want to try and say, well, how do you do this in steps? And you run one pipeline that will eventually pick it to another environment, which can then follow the next pipeline and pipeline. Again, you're allowing that iterative delivery because you've got multiple teams now coming in. So your team might focus mostly on just that. But now when it goes to the dev stage, there's a whole bunch of other teams that also might use that, and it might iterate a little bit more. And then once your pipelines run there, it runs here, and now there's more teams, but now there's more things that aren't mocked. And you break it down here before you eventually get into prod. So again, you're looking at different angles of how this will work, and there's different phases. So think beyond your team. Your team might only think of just the CI portion, because all we need is to get our code into the next environment. But as an organization, you need to again ensure that every environment that this code is getting deployed into and all the tests that are now running subsequently on that are working effectively. It's important that we have that in place. So yeah, here's just some coded examples. And this looks very basic, and I think it's because it's not that complicated. I do have some more complicated pipeline examples in my Git repo, but again, just a pre-deployment test and a post-deployment test. The real magic really just lies in maybe a shell script. You just want to check that the DB's up. You just want to check that maybe your server's up and running. You know it's healthy, there's no problems. You can script something in there. Within your actual YAML files, that's something that you can very quickly just insert. You have a pre-deployment test. You have a post-deployment test. So after you run your deployment script, you then just have another task where you just say, I'm going to have my post-deployment test, and that's what I want to do, and then I can run some other bash scripts, or I can call another piece of code that I've written that can go in and check something. A very simple way of being able to do it. Here's an example of just how do we measure code coverage and parse rates. This is using Kobatura, but as you can see here, I have set the code coverage target to 90. Just one line of code can change the world. And I think sometimes we're just too afraid, again, to use our CI/CD pipelines properly. And really, it's just utilizing the tool. You know that your tool is coming back with some sort of thing. Just by setting an input and having a target, I can stop it from going beyond that. If it's not good enough, it fails. It can be your friend. And again, it sounds sometimes a little bit difficult if you try and think, well, that's a lot of code coverage, the developer's going to be upset at me. But it's just one line change that you can add into this check can make a world of difference. And hopefully that's one takeaway you're going to get from this talk, is it's actually not that hard technically to do this. It's actually more of just a culture and process change that's really required to get your teams accepting this. Here's an example of just ensuring successful scan results. So basically, I'm just running an aqua scan on code on the left-hand side, and on the right-hand side, I've just got my policies, and I'm just setting my policies of what's accepted in terms of values, and then I have my violating severity. So anything critical, high, or unknown, I'm going to say, well, that's a violating severity. If that's true, failed the build. I've run a security scan, something's gone wrong, don't progress any further. You can configure that how you want to do. So as an organization, you can find, again, what your definition of good is, what we're comfortable with, and you can start to put the right building blocks in place to be able to make it work. But again, it's something that you can do. But there's more to it. And I also want to just briefly talk about observability. Because again, I think one of the biggest mistakes we make when it comes to our CI/CD pipelines and putting quality gates in place is a CI/CD pipeline is something that we build and we only ever look at when it fails. As long as your code's going through, do you really care? If nothing ever gets logged in production, you don't have any incidents or issues, you just assume that it's okay and you just let it run. Observability and what you're able to look at and the data you're able to gather within your CI/CD process also helps. And quality gates help to be able to check some of that stuff because you're constantly measuring an example and an output and you're able to track on that. So you want to be able to go and you want to collect data across your CI/CD pipelines, maybe your different systems, what's going on from a performance perspective while I'm running the pipeline, what's going on, within my ticketing system, within my defect system, within the CI/CD pipelines, how often are they running, how often they're failing, putting all the stuff together, storing it someplace, maybe using APIs to do all of that for you if it's using a separate thing. I normally find that tracking your data outside of your initial repo is probably the best thing, because if you're just tracking it within your repo and you're trying to use your repo tools, you're limited to what the tooling can do. But if you're putting your data into somewhere central, you can shape it and get the information you need, and that just opens up to more power for yourself. And just by using that, you can start to look at your logging, look at your monitoring, actually start to track how effective your quality gates are, how effective your CI/CD pipelines are, and look to start to monitor, optimize. And we normally set up alerting for things that happen in production. If something falls over in production, we want to be alerted of that. We need to know. But what if one of your CI pipelines is regularly failing? It's never making it to the test environment, but it's failed 100 times. I think that warrants an alert. You should have, again, certain things that you can put in place within your observability to say there's unusual behavior somewhere. We've got a problem we need to address. Maybe a part of the application is particularly difficult. It's difficult to test. There's buggy code somewhere that we've got to deal with. And it hasn't gone into production because our quality gate's catching it, but it's still not great that it's not going through somewhere, and we have the monitoring to put in place. So that observability helps you to constantly refine. And here's an example of what a quality gate, a dashboard could look like, where you're starting to track things. What do your code smells like? What's your coverage? Obviously, a lot of this is just zeros. It's just a demo board that's been set up, but really useful to be able to just again try and see what is it that we can track. What are we putting together? What have we picked up within our CI/CD pipelines? We're not just even focusing on what's going on in production. Just by understanding our development process better, we can enhance and improve it. And I think it's a big gap that we don't always focus on, because we're just, again, trying to push into production all the time. And we think a CI/CD pipeline is just going to get it there. But we need to constantly refine and improve to be able to get it there. So hopefully all of this is going to help you understand the importance of CI/CD pipelines. Hopefully all of this is going to help you realize why quality gates are important to have in that process, and why you need quality gates to build trust in the system. But hopefully it's also giving you a little bit of understanding of how you can achieve this as well. I've put another repo down there as well. You're welcome to take a picture of that as well, where there is a little bit more of an end-to-end one in process, where it basically runs you through a dummy bank in GitHub and runs some of the checks I spoke about. Go ahead, play with it. That's not the world's most amazing pipeline, but it's got the quality gates that you need to go in there and check. So it's important foundation block to be able to put in there and to start practicing and seeing how it can be done and implemented within your space. So very useful to be able to do. But hopefully this is something which is going to help you in your organization to start building that trust and getting that trust back, and making sure that you as developers can have full confidence that when you say, it's fine, it's passed my checks, I'm good to deploy, you know it's good to deploy, your team knows it's good to deploy, and most importantly, your company knows it's good to deploy, because they trust their development team. Because when the team says it's done, it's actually done, and it works. Right. Thank you.